real solutions. So we gotta find our real solution on this doubt. So that means we have to factor him. So in order to factor him, we need to find some zeros. Oh dang, we got some crazy going on. All of them, we could take an x out. Take an x out first. So we take an x out. Then we get x to the fourth minus x to the third minus 3x squared plus 5 x. 5x and then minus 2. And the reason why I noticed that right away is because there was no constant. You gotta have your constant so you guys can find your possible rational zeros. I like that constant too because there's not very many factors of that guy. So we're doing our P over Q, for possible rational zeros, which is kind of weird. Wouldn't it be better if they said C over LC? Yeah, because that would be constant. That would be leading coefficient. That would be the one right here. I'm ignoring this x. He's just going to chill out there for a little bit, okay? Okay. So for our constant, what are the factors of him? Plus or minus 1 and plus or minus 2. For our leading coefficient, what are the factors of him? Plus or minus 1. So that means we have a grand total of 4 possible rational zeros, which is actually kind of pleasant because, nobody likes doing synthetic division 1,000 times. All right, so let's try one of them. 1. Let's try 1. Yeah, let's start with 1. Okay, so we have a 1, a negative 1, a negative 3, a 5, and a negative 2. And then we're going to bring down this 1 first, and then we get a 1, and then we get a 0. Then we get a 0, then we get a negative 3. Then we get a negative 3, and then we get a 2, and then we get a positive 2. Hey, yo, we got a 0. Oh, that's exciting. So that means we can rewrite this. We could say x times x minus 1. Why x minus 1? It's a positive 1. That's because positive 1 is the 0 for that factor. And then our factor is, my new factor is 2 and negative 3x. That's a positive 2. And then we have the 0 right here. I'm going to kind of ignore him. That would be an x. So what would this one be?
X squared.
X squared. So this is a...
X cubed.
Oh, snappity backity. That's just 1. Wow. I didn't write this perfectly, but anyways, I forgot there's a 0 right there. So now we got to factor this. We got to... we got to factor that? That's whack. There's not like a nice, pretty way we can do that. And actually, if we did possible rational zeros, we get the same thing. Let's try 1 again, shall we? We shall. I'm going to try 1. I'm going to try negative 1. I'm going to try 2. I'm going to try negative 2 until I find something. Okay. 1, 0, negative 3, 2. And then underneath that, let's see, we bring down the 1, we get a 1. Then we get a 1 because 1 times 1 is 1. And then we get a 1, and then we multiply 1 times 1 is 1. Then we get a negative 2. And then we get... Oh, snap. We got another 0.
Wow.
Yeah, it was 1 again. What luck is that? All right, so we have an x. I'm just going to go x minus 1 squared. Are you guys okay with that? So I don't have to write it again? Every time you take a drink out of that thing, it's like... It sounds like a... I don't know. Yeah, dolphin. That's what it sounds like. Okay, we have a negative 2 for our constant, an x term, and an x squared term. So we have x squared plus x minus 2. There's a dolphin in here. Okay, so can we factor this? Can you guys think of something that multiplies to give me negative 2, but then adds to give me positive 1?
Positive 2, negative 1.
Oh, snap. Are you serial?
Hey,
X plus 2. X minus 1. Another one? No, I'm not going to write you again. I'm going to write you once. X minus 1. Then we got this. Oh, dang. Look how cute he is. Now, wait, that's not the answer. That's just writing it in a factored form. I shouldn't have boxed it. Okay, so what are all my real solutions? Let's see. A 0, a 1, and a negative 2.
Wait, Mr. Patey, so if you...
Here's something extra for you guys. 1 has a multiplicity of 3, which I'm sure you guys noticed. Do you go bounce or do you go through with a 3, a multiplicity of 3? I'm going to graph it really quick, just because I can. We have 0, and we have a negative 2, okay, and we have a 1. Okay? Because it has a degree of 5, and the leading coefficient is positive, I know that we're going to have our end behaviors right there. So I'm going to start right here, and I'm going to go at this negative 2. Do I go through, or do I bounce off that negative 2? It goes through because it only has a multiplicity of 1. So I'm going to go through it, and then I'm going to come back at my 0, and I'm going to go through that one also because it also only has a multiplicity of 1. And then I'm coming back at the 1. Coming back at the 1, but the 1 has a multiplicity of 3. So do you guys know what to do? And he goes through, but he goes like this. Did you say ew? Did a little jig on the x-axis. That's because it's an odd multiplicity, so it goes through. But because it's a multiplicity that's higher than 1, we have to do like this little like wavy thing.
So when does it bounce?
Bounces whenever the multiplicity is even. So like if that was a squared,
Okay.
right there, then it would have bounced. A 4 would bounce too, or a 6 would bounce. A multiplicity of 6. 2 questions you guys just asked me was, how come this says 1, 0, -3, and 2 instead of this? Because I was synthetically dividing this guy right here. See, it has a 1, a 0 for the x squared, then -3 and 2. So that's what I was doing right here. I was dividing out another x minus 1. And then somebody asked, how come you didn't just factor this? That's a trinomial. Kind of, but it has a degree of 3, so it's cubic. So there's not like a trick to factoring this. Oh, well, there probably is, but I just don't know it because that's linear algebra.